Eli siis terve kaikille. Mun nimi on Milja Köpsi ja mä oon töissä ohjelmisto- ja e-business ry:llä ja mä pyöritän siellä Mimmit koodaa -ohjelmaa. Ja te olette nyt saapuneet Mimmit koodaa -webinaariin, jonka tekniikan tällä kertaa mahdollistaa meille Platform of Trust. Ja meiltä löytyy täältä kaksi kaunista kasvua, Jarkko Moilanen ja Pirkko Laitinen. Heihin kannattaa tutustua ja Platform of Trustia kannattaa seurata, sillä he on luvannut järjestää meille lisää sisältöä. He on tekemässä meille webinaaria datasta. Heti kun tiedetään tarkemmin, että miten aihetta käsitellään, niin uutiskirjeessä ja sosiaalisessa mediassa saatte siitä tietoa. Mutta tänään meillä löytyy aiheissa, sorry, I forgot we were supposed to speak English today. So, sorry. So welcome everybody. Could you Joel just introduce yourself and the topic of the day, and let's go.
Yes, absolutely. I hope you can hear me well. If you confirm that one. Perfect. Absolutely. It's great to be here and thank you for having me. I am Joel Reijonen. I'm working as a lead data scientist at Ericsson. In addition, I have quite wide background in machine learning, artificial intelligence, cloud systems and platforms, and also cybersecurity from both academia and also from industry. I want sincerely say that you are warmly welcome to join in this webinar. I hope that you have been safe and sound, and I could start the screen sharing and the presentation. Just one moment. I hope that you can see my screen.
Yes, we can see your screen, and just one head up, if you have any questions about today's content, please use the chat box and put your questions there, and we will get to those later after Joel's presentation. Thank you.
Yes, absolutely. Thank you, Milja, for pointing that one out. So let's have the discussion and questions and answer in the end of this presentation or webinar. In this webinar, I try to be educative. I try to provide some facts. I try to provide some theories and the real life use cases for machine learning, and I try to a little bit demystify the concept of machine learning. What is the hype around it? Is it a well-marketed buzzword, or is it more like going towards this kind of a critical tool for modern automation? So basically, I try to be educative, but I hope that I don't go too much into the details, which is not my intention. I try to keep it as educative and also as a webinar that is easy to follow. So let's hope that I will success with it. Yes. So this webinar will be considering basics of machine learning. When I started to create this webinar presentation, and when I was actually thinking what should I discuss, I was firstly thinking about creating the motivation. What is the reasoning? Why should one know or be interested about machine learning? And there are a couple of use cases, but since we have now this woman who code Mimmit koodaa program, and attendees are mostly interested about the programming related issues, I hope so. So I want to take this kind of a software approach and how softwares can utilize machine learning to actually exceed and propose and provide features and functionalities that are important in nowadays software landscape in a way. So the fact is that we are living in a connected world where the connected devices and users produce more data than we have ever seen. So this is quite interesting time to be involved with the tech business, because we have already now quite many connected devices, but it is forecasted that billions of new connected devices will be connected to the cloud and internet in the form of IoT devices, platforms, and then again mobile devices, PCs, laptops, servers. And we are at the moment, as we speak, we are having this webinar through the connection. So we are quite connected in the nowadays world. And basically just to give another example for motivation, according to Domo's Data Never Sleep 5.0 report, the users watch approximately over 4 million YouTube videos every 1 minute. So that is really many videos, really big workload for the servers. And there are a couple of interesting questions when we talk about these kind of phenomenons that we are facing. Firstly is the question, how do we cope with such high volumes of data? The data volumes are massive. It is very hard for a human to actually understand and process these massive loads and dimensions of the data. Second, maybe one motivation is that how do we ensure that services that are functioning today will also function on tomorrow, when more and more devices are being connected and more requirements the services will need to tackle with when it comes to the connected devices and services that we can provide. And maybe in here machine learning may become handy, and I try to give you some ideas why machine learning could be one of the key enabling methodology or a technique to overcome such issues and challenges. So before we go to the machine learning techniques as such, I want to define what is machine learning. So we will have our own common terminology. So what do we mean by the machine learning? In nowadays, if you take a look on the news and social media, there are a lot of discussions about the big data and machine intelligence, artificial intelligence amplification, and also the machine learning, which is the topic of today. So basically how machine learning is different from these ones and how it's being somehow composed. The idea is that in machine learning as a field of study or as a field of technique, the idea is that we have a machine that has an ability to improve its own performance independently. And this means that basically we have a computing device that is in a certain environment, and based on the environment and the data that it can observe, it can actually optimize its own functionality in a way that it's more suitable in that kind of an environment. And that is the uniqueness in machine learning. It brings somehow this kind of adaptive capabilities for the machine. So a human developer doesn't necessarily need to go there and create some policies and rules. How do this machine learning system or this computing system should function? By using machine learning, we can remedy these kind of workloads by actually allowing the machine to learn from the environment and learn from the experience. And by doing so, the machine can then strive and extract additional information that is also referred as a hidden information from the data. And this is something that is not obvious. When one takes a look on the data set, it might not be too obvious to actually witness which is the component that is impacting the most, for example, to the system performance. And as I mentioned on the previous slide, the fact is that we have never seen this much data that we have nowadays. So the volumes of the data, the multidimensionality of the data is really increasing, and it's really hard for a human to actually process that data. And as a human, it's often the case that human gets easily lost into the details, whereas machine learning functionalities perform well in these multidimensional data cases. Of course, it is worth to mention that human, on the other hand, performs well with tasks that require improvisation. So there we are really good at, and that is something that maybe machine learning needs to develop themselves, and that might be actually a part which falls in the category of artificial intelligence, which I will discuss in the end of this presentation. So basically, how would I describe the machine learning? Since now I have defined it, and now I would like to describe what the machine learning is. How does it function? So we all remember when we were back in school, and we were in a math class, and there we were finding, for example, what is the 3 plus 1, and basically here we have the rule that plus means addition, and the data here is 1 and 3. So basically, when we talk about this algorithmic programming, we just apply the rule and the data, and we get the answer, which is 4 in this case. And this is how we function most of us function when we have this kind of mathematical problems. In machine learning, I want to put some emphasis in the new way of thinking. So when we apply a machine learning into a computing system, the idea here is that we actually have the data and the answers. So as an example, we might have that we have input set of 1 and 3, and then we know that the answer is 4. So with machine learning, we try to actually find the rule, and we want to construct the rule, which is in addition in this case. And that is the main difference between algorithmic programming and machine learning, if we put it in a this way. So in addition to this new kind of thinking and the definition of machine learning, I want also a little bit discuss about the functionality. The core functionality of the machine learning is composed from an idea of constructing a model. And in this model, basically, it may look a little complex, but basically in the model, the idea is that we have input data, which can be, for example, this 1 and 3, and then we have an output which is 4. And basically, it is the model's responsibility to actually construct these computing nodes, which can be seen as the blue circles, and find these connections between these computing nodes in a way that we can actually generalize the rules by applying this model on top of it. So what I'm trying to actually say is that when we have machine learning system, we have a model, and the model is basically adapting, and it's trained based on the data set that it can utilize from the environment, as an example. And based on the data set, the learning actually happens by updating the weight values, that how do we weight these outputs from the inputs and also the outputs from these computing nodes in a way. So the model might be complex, but the idea is that we basically tune the model, we construct it, and we train it, and by doing so, we have basically a computational model that is capable to finding the rules for the system, and therefore we can personalize the machine to actually understand and learn from its own environment and to perform in a more optimal way. In machine learning, we have multiple techniques where the rough separation, which I will present here, is the supervised learning, unsupervised learning, and other learning techniques. Because in machine learning, we have multiple different kind of use cases and scenarios where do we apply machine learning. Sometimes we don't have, for example, the output data available. So then it would make sense to actually use unsupervised machine learning, and that is a technique that basically focuses on problems where the output data is not available. And based on that one, we can identify from the group of unsupervised machine learning techniques, we have then methods where I will present the clustering method. There are other methods as well, but I want to basically introduce the most popular machine learning methods that are utilized in the industry and academia. And also I recommend to take, if you get interested, I will recommend to take a look further on the other existing methods as well. And basically, in addition to unsupervised machine learning, I will discuss about supervised machine learning, where we have classification and regression, and also the other learning techniques where we have reinforcement learning and deep learning as well. So I will start with the supervised machine learning. So as I mentioned in the example, when we construct a machine learning model, basically here the idea is that we have the output data available when we talk about supervised machine learning. And here the key idea in supervised machine learning is that the computational computing machine is able to learn from training set of examples or experiences in the past. And here the training set is basically composed of a labeled dataset, which means that there are real observed input and output values. So in this case, we want to construct a model that generalizes and generates the rules. How do we apply the raw data, which can be seen on the right-hand side on the image, in a way that we can, for example, classify each blue circles into a same class, or these purple diamonds in the another class, and also these orange triangles in the third class. And the idea here is that basically the goal of supervised machine learning in general cases is to predict a class or a value. So when we go further in the classification part, which is one of the methods that I will present here, is that the classification-based machine learning is a method that determines for which output or a class does the sampling of inputs belong to. And classification is widely used in applications such as image recognition, pattern detection, and natural language processing. And here the idea, if we take very pragmatic example, we can see that classification is a machine learning model that is trained with the images of cats and dogs. And the idea here is that when we feed the number of images from cats, and we know that this image is a cat, so here the image is the input, and basically the output is the cat. So we understand that this image is a cat. Based on this kind of data set, the supervised machine learning method called classification can create a model that is really good at detecting cats and dogs. And let's say that we have also turtles oncoming. We can also apply turtle data in there, and then we can have 3 classes. So the machine learns from the data that it's being fed to the system to classify that, okay, this image is a turtle and this image is a cat. And to put this very same method in the potential industrial use cases, here the idea is that basically the surveillance, quality control, and for example, system health monitoring are very applicable real-world use cases for classification tasks. Because in this one, we want to, for example, in quality control, we want to see that we have, for example, tomatoes. We want to see that which of these tomatoes can be sold and which of them have a bad shape or have a bad quality, so they cannot be, for example, eaten, and therefore they shouldn't be belonging in the shop in the first place. So this is a real-world example in classification in a sense. Second supervised machine learning method which I would like to describe and introduce is the regression. And the main difference between classification and regression is that in regression, the machine learning model strives to learn how do we map the input values that we receive from the dataset to the output values that are numeric values. So instead of having classes, we are dealing in regression with numeric values. And basically, if you take a look on the figure, the graph on the right-hand side, the regression here is not a classification rule. So it is not a rule for classifying. It is basically a line that describes how this data set, for example, develops based on time. So basically, it's you can think it can be trivially a linear regression can be regarded as a line that is basically going through the data set in a most representative way. And the key here is that in regression, instead of classifying the data into cats and dogs, the idea is here that we take or we use regression in applications that take advantage of estimations, predictions, and forecasting. So as an example, a temperature forecasting is something that could be done by using regression. And when we talk about potential industrial use cases, battery power consumption is something that we can predict or forecast by using regression, and also power plant engine load optimization. And maybe some of you might apply the regression to stock market prediction. Who doesn't want to make some extra money? So regression could be one tool to actually take a deeper look into that one. But I must say that the stock market prediction is really hard, but regression would be a tool that could work also in that field as well. Then again, as I mentioned, the 3 different machine learning techniques that I'm going to present here, the second big family of machine learning methods is called unsupervised machine learning. And here the idea is that we don't utilize the output values, or we don't have the output values available. So we only rely on the input data values, And then we do this kind of a self-guiding learning, which is basically referring to an idea that we have a raw data set, which we can see on the right-hand side on the image. And basically we feed this raw data to the unsupervised machine learning system, and it is the responsibility of the machine learning model to actually find and extract the main features of the data and find some insights that might be quite hard to find out by using, for example, simple rules. And I want to put some emphasis that each one of the machine learning techniques are quite capable to process multidimensional big data, which is challenging often for a human. And also if we have different kind of devices that produce big and multidimensional data, but each one of the devices is very different, it is quite laborious to generate rules for each one of the system individually. So in that case, the machine learning can be also a handy tool, because we don't need to basically generate generalized rules. Rather, we just apply the machine learning in the computational system, and we let the computational system to learn from its own data to find the insights. And basically the key idea, as I mentioned, is to find the main features and the structures of the data, which can be hidden or hard to see in a way. And the main goal for unsupervised learning methods is to determine the groupings and the pattern of the data. So one method, a widely popular utilized unsupervised machine learning method, is called clustering. And the clustering is an unsupervised machine learning method where the inputs with similar features and attributes are allocated to the same cluster. And when we talk about clustering, the applications where we can apply it can be taken as image analysis, data mining, and pattern recognition. So as an example, if we think about potential industrial use cases, customer clustering can be one of the topics. In that case, we need to have the customer data. And based on the data, we can find out some similarities from a single customer group. So for example, if we have a customer who often buys a product X, it has high probability of also buying the product Y. So in that case, if one takes advantage of clustering, for example, in retail, they can actually tailor the advertisements in a way that, okay, you have bought the product X, you might be also interested about the product Y. And that can be found by clustering the similar customers with similar behavior patterns or preference patterns. And by doing so, we can gather a higher understanding how the customers are actually functioning in this kind of retail system in a way. In addition, I want also to put emphasis that clustering could also be utilized in fault detection, in power plant engines, or maybe also in automotive use cases if we have engine-based vehicles and we want to see that, okay, from these conditions, it's highly, or this is belonging now to the cluster that we have high probability, for example, having an anomaly in the engine performance or even upcoming failure in a way. To also go through the other learning techniques, I will here describe the reinforcement and deep learning, which is maybe the most popular other learning techniques. And why do I call them other learning techniques or methods? Is because they have similarities with supervised and unsupervised machine learning techniques, but yet they have significant differences in their functionalities. So therefore, it doesn't really make sense to categorize into this pool, rather to categorize them as an other learning technique methodologies. And in this case, most of the other learning techniques take advantage of the feature extraction and rewarding policies. And this basically means that if we take a look on the right hand side on the image, we might have a raw data set, and then we have environment. And here the environment is basically the environment where a computational system works or functions. So if we take an example of the power plant engine, basically there we might have a computational system, for example, doing some load optimization. So the environment can be composed from the subsystems of the engine. So basically this computational system can then understand that, okay, if I now change the engine load, it might have the impact in the lubrication system or heating system. And this is somehow valuable information that is not maybe shown in the raw data, rather it is observed from the environment where the machine learning model is being deployed. And here the key element is that when we compare other techniques to the unsupervised and supervised machine learning techniques, is that we do the feature learning, and we have as an output, we can have some categorization, but also we can find these kind of action policies. What kind of actions have a certain causality which we want to avoid or which we want to favor? So this is the extra value that other learning techniques bring on the table in a way. And here the goal is to learn the features, achieve rewards, and also find the action selection policy strategies that are applicable for the environment and considers the raw data. So firstly, from these other learning techniques, I would like to introduce the reinforcement learning. And in reinforcement learning, the idea is that the machine where we deploy a reinforcement learning algorithm or a model, there the machine is rewarded if the actions or decisions that the machine has made increase overall performance in a certain environment. So in this case, we can think that basically the machine strive to find what kind of actions should I take in this environment so I get high rewards. So as an example, if we think back again the power plant engines and we do some load optimization by using reinforcement learning, we might get high rewards if we minimize the energy consumption, which is always a good thing. But also we can have penalties. For example, if we change the load in a way that increases the heat of the engine too much, and that can be dangerous. So by having these kind of rewards and penalties, the machine can actually learn that, okay, now I take an action, I increase the load consumption, and by doing so, the environment changes based on this action. And when the environment changes, then the machine is being rewarded or it gets penalty. And if the action leads to a penalty, the machine learning method or model will avoid this kind of action in the future. But if it gets good rewards, then it will favor these actions in the future as well. And these reinforcement learning methodologies can be applied in applications that take advantage of multi-agent systems, controlling systems, and also the swarm intelligence. So the agent systems is basically referring to a software component that is that can function independently in its own environment. So also in machine learning, reinforcement learning is often described that we have a reinforcement learning agent that is doing the actions. But in this slide, I have shown and illustrated as a machine learning model. If we take a look on the industrial use cases, as I mentioned, this can be applied in the power plant engine as well, but also have identified or put here that traffic light management is something where reinforcement learning is good at, also robotic use cases and video games. Second other learning technique that I would like to introduce is the deep learning. And to put it short, deep learning is basically a method that takes approach on learning multiple layers of meaningful representations. And what does it mean? It basically means that we understand the problem and the data by using multiple layers and by using multiple data representation. So somehow this can be thought that this is not so well. Deep learning can be used in classification as well as an enabling method, but the case in classification is that deep learning will identify other features than only analyzing if the image is cat or a dog. And each one of the layers that we introduce in the deep learning introduces the new extracted features. And the applications that take the advantage of deep learning include near human level image classification, speech recognition, and natural language processing. And here I have also put out that robotics is one industrial use cases where deep learning could be applied. Also advanced system management. So if we have a very complex system and we need to understand multiple representations of the system status based on the data, then the deep learning can be a handy method on these ones. And also the digital assistants are using the deep learning to actually improve their own performance and the user experience. So when I try to put deep learning in an image that would make sense, if we compare the deep learning to the traditional machine learning approach, and traditional machine learning approach here means that we have an input of a data source that can be, for example, a ship or an engine of the ship. So basically there is then a developer or a data scientist that might do some feature extraction manually, or that person can also be a system expert who knows all about the system and therefore he or she can then put the meaningful representations on the data. And based on that one, we can train a model for fault detection, and based on that one, we can identify whether the system status is facing a failure or not. In deep learning, on the other hand, the idea is that we basically replace this developer by just adding a new layer to the machine learning stack. And in that case, basically the deep learning would utilize the input data, for example, from the engine, and it would do it automatically and independently, the feature extraction, and then the fault detection, and then basically producing the result of the prediction if there is a failure occurring or not. Here, of course, this seems quite advanced, but here the thing is that when we add these multiple layers of representation of the data, the computational complexity also increases. So deep learning is quite complex a tool to be used, but it can be rather applicable when we have a right use case. I would like to also describe and discuss a little bit about neural networks. So neural networks are a really common way to implement almost or actually every previously described machine learning technique. So neural network can be regarded as an implementative approach. A neural network is something that you may already have seen some blog posts or posts in social media about neural networks and their relationship with machine learning. So therefore I wanted to address that what are these neural networks and how they are related with machine learning tasks. So neural networks are originally inspired by biological neural networks, where a high number of interconnected neurons process the information in parallel. So neural networks, in other words, take advantage of massive parallelism, and that can be seen on the right-hand side in the graph, where we might have this kind of computational nodes, which are these blue circles, and these are also referred as a neuron when we talk about neural networks. And the connections where we have these W values, these are called synapses. And as described previously earlier in the webinar slide set, there was a representation of a computational model, how it is being composed. So this is the relationship that neural networks can be used to compose a machine learning model. And here basically the machine learning happens actually by modifying the weight values. And the goal for these neural networks is to achieve the human-like or human-level performance in a wide field of application. So as I mentioned, the previous examples that I have given, they can be implemented by using neural networks. There are also other approaches how do you implement your machine learning methods, but neural network is maybe one of the most popular ones. And also, since this, as I mentioned, that the weight values are the place where the learning happens in the neural network, so the neural networks needs to be trained before the model is complete. So in this case, the neural network training, and generally in machine learning, most of the models are trained in an iterative way. And here it means that we repetition and we feed the data many times to the network in a way that the network can learn the performance, or it can actually learn the causality of the environment and the proper actions, or it can learn how the input is mapped to the output. So basically, here we can think the slide about having this kind of different approach and different way of thinking, where we generate the model that is actually providing us the rules for the system. And here the idea is that when we train the neural network, we have some output, and basically we observe the output, that if the rule that is constructed within the neural network, if it's producing inaccurate outputs, then we know that our rule is bad. And therefore we guide the network again by using loss function and optimizer to modify the weights in a right way, that we actually fine-tune the model which produces in the end of the day accurate results, and then we can apply it in the wide field of industrial use cases and also the other applications as well. So that was briefly about machine learning. So I would also like to a little bit discuss beyond machine learning related topics. So for example, if we think about the relationship between artificial intelligence and machine learning, here I would say that the machine learning is the essential concept when we enable continuous learning from examples and experience in the past in an artificial intelligence system. So if we think about artificial intelligence, there are two most obvious functionalities that one could describe, and one of them is learning, and second one is decision making. So firstly, the learning basically refers that we understand the data, or we understand the causality that we cause in the environment by taking some action. So based on that one, we learn how the system behaves and how do we optimize, for example, the accuracy of detection, dogs and cats, or the engine system performance, or how do we map a regression model to in stock market prediction. But then the other hand, when we have learned and we have the available model that has utilized the learning to tune the rule system in a way, then basically the second high-level topic is the decision making. So when we have the system has adapted to its own environment, then the second part is to take advantage of this learning and basically create meaningful decision. What should we do if we have a failure in the system? So if we take once more the engine example, here the case is that we want to learn which kind of input data and factors are impacting to the fact that we have a failure. That is the learning. So we learn the causality and the relationship between these two topics. And then the decision making in the second part is that what do we do when we have a failure incoming or an anomaly? So basically, or based on these inferences that we utilized or utilize by applying the trained model, then basically the artificial intelligence can perform the decisions by taking advantage of the deduction logic, and that is basically that deduction logic is also one way to do the decisions by applying the idea that this has been previously a good decision and therefore I will apply it now as an example. Another topic when we discuss about machine learning is the data. The data is the fuel for machine learning. So in order to achieve reliable results in machine learning, the raw data needs to be pre-processed, because raw data often include noise, redundancy, missing value and domination. and there might be also other factors that might impact to the data that may cause really counterproductive effects. And the proper data preparation is a preliminary requirement for efficient machine learning, because if we don't pre-process the data, we will teach the system by applying a data set that is in the first place describing very wrong things. And that this is the case what may make your machine learning projects to fail. So this is important topic that needs to be considered when machine learning is applied. Then again, if me with Coda and women who code want to apply and learn how to become a master in machine learning and maybe in data science as well. So in machine learning, I would highly recommend following skills. I don't mean to be expert in each one of these, but I would recommend to get a little bit familiar with the topics, because it helps you understand how do these models work and how can I implement my own machine learning model. And first is the linear algebra, calculus, probability theory and statistics, and also theoretical computer sciences. And these are something that you can read from the research papers or from blog posts or something like that to get yourself familiar with the theoretical parts. And when you start to get more familiar with the topics and you feel confident with these methodologies, then I would highly recommend to learn Python, R, or C++ as an example, because they are most trending programming languages when we talk about machine learning. But as I mentioned, I also want to put emphasis on the theoretical part, because it helps you to guide your programming processes and your programming projects that you want to apply by using machine learning. Also, when we talk about machine learning frameworks, I would recommend the following. So TensorFlow, PyTorch, scikit-learn, Keras, and MXNet. And these will be helpful tools to get you started. And as I mentioned as before, you don't need to get expert or expert level experience by learning these frameworks, but just to get an idea how do these frameworks work. And these frameworks have some differences on the logic, how do they work and how they are built. So basically I would then recommend to check out each one of these and see which is good for you and which of them frameworks has the same somehow a logic that is most suitable for your points of view and from your current level of experience. Yes, I want to thank you once more. This was really interesting to have it remotely. I hope that this was educative, and I hope that you learned something from this webinar. And now I would like to take some questions, and I would like to provide as accurate answers that I possibly can provide. Thank you.
Thank you, Joel. So awesome, super awesome, and the content was really sorry, how do you say ymmärrettävä in English?
Understandable.
Yes. So there's can you see the chat box?
I'm actually on the presenter mode, so I cannot see.
So let's start with the questions. Can you give the concrete example of a reward or penalty in reinforcement learning? What does the machine value? And Jasmin, if you want to add something, we can unmute you.
Hyvä.
Yes, absolutely. I cannot hear anybody commenting, so thank you for your question and thanks for the interest. And a concrete example could be for example, if we think about that we have a computer system, and in the computer system we can regard that we do some resource management. So for example, our system is trying to basically play a video from a media player, and at the same time you want to browse, for example, some web pages. So in that case, the computer needs to split the resources, that some resources needs to be put in the to run the video system, and some resources need to be put in the browser. So you can do them at the same time, concurrently. So in this case, if your computer system is utilizing reinforcement learning, here we can think that the rewards, the system gets more rewards if the user, such as myself, if I don't notice that, for example, the video is lagging or there is much buffering ongoing, and I can at the same time seamlessly browse my web pages. So if I manage to do that one and the user cannot feel any kind of difference, then the computing system has balanced the resource management in a way that it's wise and it uses resources efficiently. So basically, this can be something that the system is highly rewarded if this happens. However, if we have a scenario that the video is buffering quite much and it's lagging and the voice is not coming correctly, then basically these scenarios can be cases that then the machine learning method in reinforcement learning starts to get penalty. And then the machine learning agent or the computing system will avoid these kind of resource management actions that lead to this kind of a bad performance and bad quality of the experience. I hope that this was a little bit clarifying, but thanks once more for the question.
Thank you. Ja hei, jos haluatte kysyä myös suomeksi, niin se onnistuu. Jos tuntuu turvallisemmalta, niin voitte kirjoitella myös suomeksi sinne. So Jasmin continues, thank you, but what is the reward?
Yes, really good question. Reward is actually a number. So since we are talking about the computational system, we need to map these rewards. So for example, this kind of a good or bad experience will be represented as a number. So let's say that we have a slight number of buffering within our video or small amount of lag. Then we give the penalty of -5. And if the user experience is horrific, then we might have -100. And basically this number describes the impact of the penalty. So we can then fine-grain the penalties and rewards that if this was a really good action, you will get 100 as the reward. And if you get good experience, everything works, but there is still much to improve, you might get like 10 points. And by doing so, the machine can then, the machine wants to maximize the number of rewards and the amount of rewards. So that can be seen as a reward to put it very concretely.
Thank you. There's one question about the slides. I was thinking that we could do the short blog post about the introductions to the topic and then add your slides there too and the tallenne of this webinar. Is that okay with you? Can you share the slides?
Yeah, absolutely. Absolutely.
And Jasmin said that, aha, now I get it. Thanks. So you are really actually good. Helping.
This is honey for the presenter to actually make people to understand. I'm very grateful and I'm very happy to help you.
Thank you. At this moment there is no other question. Yes, there is. Let's continue. How about when there is still not a big amount of data? How to proceed with machine learning?
Really good question. Really good question. Thank you for this one. So as I mentioned, the data is the fuel for the machine learning. And if there is little amount of data, we can think that we put too little amount of fuel into our car. So we can get somewhere, but it is not convenient because we cannot, for example, drive to work or drive to home. So the data issue is really relevant, and in conventional machine learning and traditional machine learning, the number of data points and the volume of data should be quite high until we reach the convergence of the machine learning model. And this basically means that we have so much data available that when we feed the data to the system, it doesn't anymore improve. So as an example, if we have 1,000 data points and we want to basically predict if the image is cat or a dog, 1,000 images could be sufficient enough that basically when we have the 1,000 images, we can do really reliable detection that, okay, this image is now cat, this is a dog. But if we have only 2 images, it can be quite hard, because if we have different cats that we try to observe and the first image was very different from that one, the machine cannot understand it very well, and therefore the performance will be quite bad. So the data is something that it needs to be enough, but it depends on the use case what is enough number of data points, but the data should be emphasized, and it's the fuel of the machine learning system. Also, as a side note, there are a small, well, let's say not small, but increasing topic of research which is focusing on small data-driven machine learning, and there the researchers and developers try to apply small number of data points and create meaningful machine learning models from there.
I really like how you provide really clear examples of things. Thank you. Ezra said yes, very clear. Thank you for the answer. And Jarkko said saturation point is achieved, got it. And Riina is asking what kind of tools are best for the pre-process data?
Very good question. I really like how much participants have put effort on these questions. I really enjoy these kind of sessions. I'm very happy. In pre-processing, there are in fact pre-made libraries. So for example, if you are familiar with the Python programming language, there is Pandas and NumPy, which I would recommend to take a look on. From there, you can find some data structures that help you to process multidimensional and big data, and there are already pre-built pre-processing functionalities, such as filtering and missing data management. So those would be the frameworks that I would highly recommend to take a look on.
Yes, thank you. Now we are through with the questions. So, no, Jannika said something. Wait. Yes, I'll wait you, babes. I have been working with data now for a couple months, and it seems that it's very how you pronounce this, scattered, easily corrupted, etc. How can you make sure that that data is good?
Yes, one other excellent question. So here the data quality is something that in addition to the data quantity that I described when we were discussing that how much data do we need for machine learning, the quality is the second topic that needs to be concerned. And basically, if the data set tends to have corruptions, then the thing is to actually create pre-processing data pipelines and functionalities that actually will calculate new values for your corrupted data points. And how does that happen? So as an example, we can have a data that is growing in time. So we have 1, 2, 3, then we have a corrupted data point, and then we have 5. So in this example, we could interpolate the value because we know that one value beforehand was 3 and one value afterwards was 5. Then we can deduct that the corrupted value most likely was 4. And this is something that we can apply in these scenarios when we want to make sure that the data has the proper quality, and also we want to make sure that we have right amount of data available when we talk about both quality and quantity. Also, when we talk about machine learning, corrupted data points or very bad measurements can be also removed from the data set if they are hard to interpret. What did they mean? But also to keep in mind that one should not remove all of the data based on these factors, because if the data is in bad shape, there might be a scenario that it's hard to basically construct a valid data pool for machine learning.
Yeah. Next one, does it matter much if the data coming in is multiple dozens of data schemas, how you pronounce that, and formats? Does it make it harder?
Yes, so basically there are two cases when we deal with the data when we apply machine learning. So first one is when we train the model. So in that case, when we increase the number of data points and when we increase the dimensionality of the data points, that will of course impact to the time that is required for the model training. And as I showed previously in the slides, for example, these neural networks, if we have a multiple layers and we have very many of these computational nodes in the network, it can actually extend the training time exponentially. And then we can talk about training times that may take hours, days, or even weeks, even though we would use a cloud computing platform. So in that case, it is also relevant to investigate which of the data points are actually relevant and which of these data points actually represent most of the data set. And this field of science is furthermore called as a dimensional reduction. And these dimensional reduction methodologies are extremely helpful when we want to decrease the time that is required for model training, but also we want to provide highly accurate results by using these machine learning models that have been trained with such data sets. On the second hand, when we have the model that has been trained, and then we do these inferences, and the inferences basically means that we feed, let's say, an image to the system, and we don't know what the image is. We can, for example, if we think that we have a video camera where we have a machine learning functionality and it can recognize cats and dogs, and you will go to the zoo with this video camera and you have it all the time on. So in that case, the machine learning method has no time to train the machine learning model and improve it. So in real time, when you scan with your video camera, for example, lions and tigers, you might get some recognitions that these are cats, or most likely cats, or cat animals. So this is the real-time prediction by using the machine learning model. And there, of course, if we have complex data schemes or data models, the case is that the amount of time that is required to do the prediction can get quite high. So if we have this video camera and we go to Korkeasaari and we scan some tigers, and if there is a huge delay, that means basically that we have too big amount of data and our model is processing a long period of time to actually give you the answers, and that might end up of having a bad user experience, because it doesn't really make sense that if you scanned or recorded a tiger and then you move to record a dog animal, let's say a wolf, and then when you are basically videotaping the wolf, and then it would say tiger because there is so high delay on the data set. So here again, the importance is to find out the use case and the application, and here as well the dimensionality reduction for the data is important. So when we deal with the massive amount of data, there is always the question of how long does it take to basically compute the results, and how much does it basically stress your computational system. I don't know, does Korkeasaari have tigers, but I hope so. So this example would be more valid then, but yeah.
Jarkko answered it. So as platform of trust provides data streams in harmonized format regardless of data source system with trust value quality, it most likely makes machine learning easier and efficient. Excellent. We are our time is up. I really want to thank you, Joel, about this, your time and all your excellent esiintymisesi. Great presentation. Thank you. There's lots of people in our chat saying thank you, and great presentation. Would be nice to hear even a more detailed one regarding machine learning. Let's discuss about that later. I think you can find Joel in LinkedIn, so please do have some networking. and I will get you later with the slides and the uploaded YouTube video. And if you have any other new questions during the weekend, you can send those to me, milja@mimitkoda.fi. So I will get those forward to Joel and we'll figure out the questions to you. Thank you, Jarkko. Thank you, Pirkko. Thank you, all the ladies and gents in there, and see you later. Have a nice weekend. Bye.
Absolutely. Thank you. Have a nice weekend.